Okay, advanced math or pre-calculus, whatever you want to call it. First off, I hope everybody's safe and well, and I hope you're staying away from people who don't live in your house. Okay, don't get together. And you've heard it all before, but take this seriously. I know we are. Okay, so here is where this course is going to go. I don't know when and if we'll see each other again, but we're going to try to cover as much as possible. So listen, for right now, we are going to go to section 4-1. Okay, not 3-1, 4-1. And the reason is because some of chapter 3 are things that not only have you seen before in, say, Algebra 2, but also maybe even earlier in this course. The first section, 3-1, is about parabolas, which we have done before. I'm not saying we're not going to go back and do it, but for right now, let's make sure that we get to the stuff that we need to cover for the syllabus. So this is going to be 4-1. Now, the title of chapter 4 is exponential and logarithmic functions. Okay, and this first section, section 4-1, just introduces the concept of what is an exponential function. Okay, again, I'm saying the words exponential function. Exponential functions are a family of functions, just like polynomial functions are a family of functions. Rational functions are a family of functions. Trigonometric functions are a family of functions. So this is exponential functions are a family of functions. Now, what makes a function, what causes it to belong to this family is simple. There has to be a variable somewhere in an exponent. Okay, so like for example, y equals x squared. That function has an exponent, but that is definitely not an exponential function because there is no variable in the exponent. Okay, in this case, the exponent's constant and the base is your variable. So that is not exponential. Okay, period. Now, on the other hand, if I wrote y equals 2 to the x, now notice that the base is a constant and the exponent is a variable. So that is an exponential function. So this is actually, I mean, you could call this lots of things. It belongs to the broad family called polynomials. If you want to be a little more specific, that's a quadratic function. But this right down here, that is an exponential function. Okay, because there's a variable in an exponent. Now, I'm going to write kind of the general form of an exponential function here first. Y equals a times b to the x. So this is an exponential function. Now a and b here, those are both just constants. They would be numbers. Okay, y is your dependent variable, x is your independent variable. Now b, the number that's actually being raised, in this case to the x power, that is called the base. And this, we can call that just a coefficient. And of course, x is your variable. Now, as you may suspect, the values of a and b determine or affect the behavior of this function, the graph of this function. But let's start with maybe an example where a is 1. And we'll just do probably the simplest exponential function that I can think of. F of x or y equals 2 to the x. Okay. Now, I'm sure you've seen this function before, but we have to start somewhere. Well, what does the graph of this function look like? I'm not going to make a huge deal out of this. But if I mark this off by 1s, okay. I'm not going to scale the y-axis right now. But if you think about what this function would look like, if x is 0, say my input value is 0, well, 2 to the 0 power is 1. just like any number to the 0 power is 1. So if x is 0, y would have a value of 1. Now, if x is 1, well, y would be 2 to the first power, which means that the y value would be 2. If x is 2, y is 2 to the second power, or 4. 3 is 2 to the third is 8. And you can see I'm going to run out of space really quickly because exponential functions grow quickly, or they are capable of growing very quickly. We'll see. As long as the base is bigger than 1, they'll grow pretty quickly. In fact, exponential functions can grow more quickly than any other family of continuous functions. Okay. There is a family of functions that are not continuous that can grow faster than exponential functions, but not a family of continuous functions. Okay, now I can connect these dots. An exponential function is continuous, so I can go like that. That's great. Now, what happens as we go to the left of the y-axis? Well, you've got to know a little bit about just basic, good old-fashioned math, okay? Like, for instance, let's say x is -1. That would mean y would be 2 to the negative first power. Let's get this out of the way right now. That doesn't mean -2 or something like that, okay? 2 to the negative first power is the same as 1 over 2 to the first power. So that's 1/2. So if x is -1, y is 1/2. If x is -2, remember 2 to the negative second power is the same as 1 over 2 to the positive second power. So that would be 1/4. And it goes like that. Now, okay, so I'm going to connect the rest of these. And, you can kind of tell as x gets more and more negative. I get stuff like 2 to the negative 10th, 2 to the negative 100th. Well, 2 to the negative 10th is 1 over 2 to the 10th, and 2 to the 10th is a pretty big number. Okay, so these y values keep getting smaller and smaller and smaller as we go this way. But if you also think about it, I'm never actually going to be able to reach 0 here. No matter how small of a fraction I get, like 1 over 2 to the 1,000, that's a pretty small fraction. But it's still not going to touch the x-axis. Okay, so this function is bounded below by the x-axis, and of course it can grow toward infinity as x goes toward infinity this way. So let's talk maybe about the domain and range here. Well, the domain of an exponential function is all real numbers. Now the range is not. The range in this case, remember we said it's bounded below by the x-axis. So the range would start at 0, and it's not going to include 0. The y value can never actually be 0. So the range is going to be, no, I did that. 0, infinity, like so. Okay, so an exponential function has the potential to look like that. Okay, how are we doing on time, Teddy?
9 minutes.
Okay, yeah, we'll try to wrap up here in just a little bit. Okay, now, as I change the base, okay, as long as the base is bigger than 1, you're going to get this same general shape. If the base is less than 1, all right, like if the base is 1/2, you're going to kind of get the opposite shape, and I'll go through an example of that here in a little bit, maybe in the next video, I don't know. If I put a coefficient in front of the 2 other than 1, that also changes the behavior a little bit. It wouldn't change the general behavior. If I made this 2 times 2 to the x, that would simply multiply all the y values by 2. It would move the curve up a little bit, but it's still going to have the same general shape. Okay, so I want to make this clear. We're doing 4-1. You'll find it on website. I will post a second part of a second video for this section. I might not be able to do it tomorrow. I've got 5 courses to do, and helper,
Be quiet.
he gets a little antsy after a while. So anyway, the learning will continue. Okay, rest assured, learning will continue. That is all for right now. Thank you and goodbye.